So this is our inductance meter simulation. I'll first be going over the code and then the component, and after I'll run the simulation. But our goal with this circuit is to find the unknown inductance value using the LM339 chip or the comparator chip to measure oscillation. For the code, we first include the LCD library. These are the pins we use for the LCD. These are our variables to calculate inductance. In our setup, we initialize the LCD with 16 columns and 2 rows. Pin 11 is connected to the comparator output, which allows the Arduino to read the signal coming from here. Pin 13 is connected to our charge resistor. This is a small delay to allow the setup to take place. And then from here in the loop, we send a pulse through the resistor into the inductor. Set it to high to set the top of the sine wave. We allow a short delay to allow the inductor to charge. From there, we turn off the charge, and this gives us the bottom of the sine wave. Here, the pulse is measured through the comparator. It measures the duration of the sine wave and converts it into a square wave. If the pulse is valid, we continue into the calculations. Our capacitor value is a 2 microfarad. To calculate frequency, we use the formula 1 second over period, or pulse, in our case. This 1e to the 6 is used to convert the 1 second into microseconds. And then it's divided by pulse times 2. We then move on to calculating our inductance by using the formula 1 over 4 pi squared times frequency squared times capacitor. And then we convert it from henries to microhenries. And then right here we use the LCD to print out the inductance and the inductance value. And this right here we have an 150 ohm resistor, which is used to charge the inductor. The diode allows the voltage to go through but not back. And then here we have our unknown inductor. We use the capacitor to create an LC circuit, which allows the voltage to pass between the capacitor and the inductor that then creates the sine wave, or we call it resonant frequency. Since Arduino can't read fast sine waves, the comparator chip turns the sine wave into a square wave. This is done by taking the high and low points of the sine wave. This way the Arduino can understand the values given to it. From here, a 330 ohm resistor helps charge the output or the comparator chip to give faster and cleaner square waves. This first oscilloscope gives us the sine wave, and this one gives us the square wave from the comparator chip. This is from the LC circuit, which is the inductor and the capacitor. And these two 1K ohm resistors is used to control the brightness from the LCD screen. And here we simulate. As you can see, this is the sine waves and the square waves. And then clicking on this, we see we have a 200 microhenries. We get a 234.25 microhenries displayed. That's a small error, but we're okay with it. And then giving it different values, you'll be able to see the sign change and the inductance change. Thank you.